Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to test the analog input of PLC GE. Yes, this module is IC200ALG264. It is the 15 bits and 15 channels. Okay, and here is the testing. I already connected the loop current calibrator from the connection to zero with the multimeter current, yes, milliamp, and connect to the terminal. Terminal number 1 is plus, and terminal 17 is minus. It is milliamp, 4 to 20 milliamp. Okay, and in the previous video we already learned about how to configure for add this module to the CPE 330 by using Proficiency Machine Edition version 9.5. yes, that connected with the version IO remote IO, yes, via LAN cable. And I already connected the LAN cable from my PC to the LAN number 1 of CPE 330. Okay, so this is just wiring, and I will explain more in the detail of this drawing. Okay, so the concept is right now we need to create the scaling to show example. When I set 4 milliamp, it will show the actual temperature or pressure or some scaling to show the actual value. Okay, so it is just example for one channel. For other channel we can connect minus the same and plus to channel number 1, number 2 until 15 channel. Okay, so let's go to our software Proficiency Machine Edition version 9.5 to create the scaling for show the value. Yes, so let's go. Okay, first let's go to open Proficiency Machine Edition. Okay, and then go to the existing project that already learned in the previous video. So let's go to add remote IO. It is the existing project. So for the hardware configuration and version IO, I already explained in the previous video. So today no need to explain more, because in the previous video I already explained and detailed step by step about how to configure hardware configuration or create the EGD, yes, for consume and produce, and already connect to the CPU also. Okay, so here is the module that we already configure in the previous video. So it will start from AI, yes, AI1, and we can see here Ethernet global data consume, right, because it is input. So it will start from AI1, percent AI1, and 15 volt. It means that 15 channels, yes. And I need to download the existing project to the CPU again, yes. And then let's go to check the IP address of the computer. First let's check the IP address of the CPE, yes. 192.168.0.100. So we need to put the manual IP address of the computer to be the same rank. Yes. So 192.168.0.253. Yes. Actually, if the automatically configure, it will show like this. Yes, it is the automatically IP. So we need to put the manual IP address, right? So let's go to put the manual IP address to be the same rank of the CPE. Yes, that we already connected the LAN cable to the CPE. Okay, so we need to put 192.168.0.253 or something, but not .100. Okay, otherwise it will complete the IP. Yes, so let's click OK. And right now I already connected the LAN cable, yes, from here to the CPE. So we can ping 192.168.0.100, right? Cannot connect, right? Let me check again. 192.168.0.253, right? Okay, that's correct. But why cannot ping? If we cannot ping, we can check the window firewall. Yes. Okay, right now it closed. Okay, correct. And then we can write the A or P space A to check the all IP address, the static IP address. So here 192.168.0.100. So we can A or P, type A or P space D, and then 192.168.0.100. Okay. Sorry, ARP D 192.168.0.100. Okay, and then we can start ping again 192.168.0.100. Okay, so right now we can ping. Yes, then we can go online. I go here online, and then we can download the project to the PLC again. Yes, equal. Yes. So for hardware configuration, we already download. If we not yet download the hardware configuration, we can stop and then go to download, and then go to logic. Yes, and then download all. Okay, so I will put like this, and then go to view, and then convenient. Then I will put like this. Okay, so good. And then we can go to the I/O table to test the signal of the analog input before go to create the scaling for test, right? So test table, And here is the analog input signal, right? I will run the CPU. Yes. So let's see, here is the signal from channel number 1. Yes, that I already connected the loop calibrator here to the channel number 1. Yes. So I will show if I adjust the value of the milliamp, it will vary also, right? Okay, let me show. Okay, let's see, I already connected the minus from the loop calibrator here to the terminal 17. Yes, and plus the read with the multimeter, and then connect to the terminal number 1 of carry box type at A. Yes, so right now the milliamp show around 16 and raw data around 24 something, right? So if I adjust the loop calibrator to 4 milliamp, yes, okay, 4 milliamp, it show around 0, right? Okay, so low scale is 0, and then if I adjust to 20 milliamp, let me adjust 20 milliamp, okay, 21, 20 milliamp, right? Okay, around 20 milliamp, it will show around 32,000. Yes, okay, so high scale is 32,000. Yes, so we can configure the scaling. Okay, so right now we can configure the scale. Yes, so the raw data 4 milliamp is 0 and 20 milliamp is around 32,000, right? Let me explain the drawing. Here is the drawing analog input, 15 bits and 15 channel. Yeah, this is a card module, and let's go to see the scale, right? Here is the connection. Yes, we have a current source. Yes, like this, and here is the how to wiring. So we need to connect the plus to I1, right? And I2, I3 until I15 is positive, and for minus or negative milliamp, we can connect from the terminal 17, and we can jumping to all the terminal, right? So we will got the raw data, yes, that I already saw in the ProPC Machine Edition. And here is the current testing scaling. Yes, so when 4 milliamp, let's see here, and here is the maximum. Yes, 4 until 24 milliamp, and here is the raw data that got from milliamp testing. Yes, this is 0 to 20 milliamp, and this is 4 to 20 milliamp. Okay, so this is a formula. Yes, so we can create the scale. Okay, this is just manual operation and drawing of this module. Okay, so we will create the scaling. Yes, so first I need to create the function block. Yes, because in the previous video we already learned about how to create the ladder, right? So in this section I will create the function block. So before create, I will show the formula a little bit. Yeah, this is a formula. Actually, the value that we got here, yes, it is the integer, right? Yes, here it is integer, so we need to convert to real, right? Here, so we need convert from integer to real, and then we will got the high scale parameter minus low scale parameter, and then divide by maximum around 32,000 for raw data, and then plus with the low scale. Okay, so we need to convert from input from integer to real. Okay, so let's go to create, followed by this formula. Yes, and here is the Excel file that we can simulation. Example, the scale around 0 to 100% or 100 degrees Celsius. If I put 0, raw data 0, it means that 4 milliamp. Yes, so the actual of temperature is 0. Okay, so if I put the middle, right, 32,000 minus, sorry, divide by 2, it will show 50 degrees Celsius. And if I put 32,000, it show around 100% or 100 degrees Celsius. Okay, so we can create the formula by follow this step. So let's go, and I will outline first, disconnect, and then go to the main program. Yes, okay, I will create the function block. Example, scale SCLAI, yes, as scale of analog input, and then go to main, and then here we can call, right, we can call the main, so we can call this block to main program. Okay, and we can double click to write inside the function block, right? So here is the function block that we can create the scale. Yes, so right now I don't want to create the library, so I will create one for use to show to everyone first. So we need to follow our formula, right? So convert from integer to double integer, convert from integer to real, right? This one I will copy. So Control C, and then I will write command, example text, and we can paste. Yes, this is the formula. Okay. Okay, I will zoom a little bit. So we need to convert from input to real, right? This is 0.0, right? So integer to real. Yes, and this is the input. Example input 1, or we can write sensor 1 input. Yes, and we need to create the high scale, right? Example so we can use subtract. So sub between this one, sorry, between high scale. Yeah, so example sensor 1 underscore high scale. Yes, or we can write the high scale here. Example 100.0 degrees Celsius, right? So the low scale is 0.0. We can write like this. And we need to divide this one by 32,000.0, right? So divide 32,000.0 because it is the real. And then we need to multiply by input, right? So we can use mul. Actually this one we can adjust like this. Yes, easy to understand. So I will multiply this one and this one, and we can adjust like this. And I will add with the low scale, right? So I will choose add. With the low scale. So low scale we can choose 0.0, right? 0.0, and we will got sensor 1 output. Okay, so sensor 1 actual or output, I will use actual. Okay, like this. So for this one we need to put the address right here. So it will start from version AI1 that I already connected the milliamp to this terminal. So I can use property and then put the version AI1. we already assigned, right? Okay, let me check. Maybe we use another logic. Okay, so we can copy this one to use. I will take out this one first, or we can use the channel number 2. Let me use the channel number 2. So channel number 2 is option AI 2. Yes, and I will swap the terminal from terminal number 1 to terminal number 2 of the PLC module card. Okay, so let me download the logic. We will got error 1, right? Let me check. Invalid input. Oh, this one, right? It is the real. This is a integer and this is a real. It is the real. Oh, this one, right? Need to change to real. This one also. Okay, change the data type to real and validate again. Error 2, right? So real, it is the real. Should be real. We will change the data type to real, right? All data type is real. Let me offline first and then revise the data type again. It should be real, yes. We can use the variable. Let me delete first. It is the real, right? So let me drag and drop again. Should be real. Okay, I will use the variable. Example temp1. It is the real. Yes. Temp2, it is the real also. This one, right? So this one should be temp3. The data type is real, yes. And this one should be temp4, yes. M4 also. Okay, so let's check again. Real. This is a real. Okay, input integer. Yes, correct. So validate again. So we will got error 0, and then we can download. Okay, download. I will adjust a little bit to easy to understand. Yes. Yes, like this. Then we can download again. Okay, so right now the raw data is show 0 because I already I'm not yet connect the cable to channel number 2. Yes, so let me connect to channel number 2. Okay, so right now I already connect to channel number 2, and then we can adjust the milliamp. Right now the actual temperature is show 0. Yes, because input is 0 also. Okay, so let me show the adjusting the milliamp. Right now the milliamp is 4 milliamp, right? So if I adjust to 8 milliamp, yes, let's see here around 24 degrees Celsius. Just one more. Yes, 12 milliamp around 49. Yes, it is the middle. The raw data is around 16,000. If I adjust more, 16 milliamp around 75 degrees Celsius. Adjust to 20 milliamp around 199 degrees Celsius. Yes. So the scale that we created is correct. Yes. Or we can adjust a little bit. Adjust. Yeah. The value will decrease or increase. Follow our adjusting. Yes. Okay. So it's very easy. If we have the loop for a calibrator, we can use to adjust a little bit adjust, or we can use like this to adjust step. Yeah, from 4 to 20 milliamp. Yes, like this. So the next step, we need to show this value to the HMI, right? So let's go to config the project for HMI. Yes, let's go. So first open the workbench and create the new project, and we need to put the username and password. Example, I will put username administrator, and password we can put another password that we want. Okay, I will put password. Yeah, like this, and then click next, and we need to create the new project, right? So I will save to desktop. yes, or save to dry C. And I will put the driver protocol. Yes, right now I will use the driver, yes, S9 yes, and the project example CPE 330, yes, and then go to OK, and then go to the port, right? Go to equipment and go to create the port. So we will choose the port that we already config on the option, and we will start from port 0, and here I can use 1 second. It is default, yes, no need to change. And we need to create the device, right? So example PLC 1 or CPE 1. So this is the port that we already created, and we can choose the PLC system, yes, and here is the IP address that we connect to the CPE, yes. So 192.168.0.100. So 192.168.0.100. Yes, click OK, and then we can test. We can start the project, and then we can test the device. So waiting a moment for this starting. Okay, so right now the project is started, and we can test the device. Yes, it show device up like this. It means that we can communication between the HMI with the CPE. Okay, so we need to create the points. Yes, before create the point, I need to put the address here. Example, I will use %S for show the actual temperature, right? So right click and then click property, and then go to reference address. I can put the %R. Yeah, it will start from %R1. Yes, and then I can download again, connect and then download again. Actually, this one we can also show it on the HMI, yeah, by put the %R also to check. Example %AI, right? Okay, %AI. So we will create the points. So I click dynamic and then click new point. Example sensor 1. Choose the analog and then choose device, and here is the device name that we already created. So I will choose real because I need to show the actual temperature here. Yes, so the data type is real, and I will put %R1 because here is the %R1. Yes, let's see here, and then click OK. And for description, we can also mention example temperature sensor 1. Okay, and I need to create this one also to show on HMI, right? So I need to use the new and then create the point. Example, position, no, AI2, yes, example AI2, and it is the analog, and choose the device also. So this one should be integer, right? And then I will change this one to, sorry, insert this one to %AI1, sorry, AI2, because we use the AI2, right, here. Okay, and then here we can mention the command. Example, analog node 1 channel 2, yes, and then we can go to the screen and then create a new screen, and then we can write the text string. Example, show the actual temperature I will change the font to be bigger than this. Example 16. Font size, yes. And we need to create the rectangle, yes, one rectangle like this. Change the color to be white, and I change this one to black. And then I will create the text string and write like this. Put like this, and then arrange to be center and middle, yes. And the unit I will put degree Celsius, right? So I will put like this. See, and I will adjust this one to be smaller than this. And can like this, and then change color to be white for unit, and we can group, right click group, and we can like this. Okay, so here I can copy and can rename the text to be sensor 1. Okay, and then I can copy one more for show the %AI2, right? Okay, %AI2, and then this is no unit, right? So like this. So I will change the color to be yellow. And we can zoom, yes, like this. Okay, so this is a %AI2 value, and this is a actual temperature, right? So I need to put the points, go here, and then go to the display value expression, and then choose the brow point ID, yes, and I check the brow and screw to find the AI2, yeah, here, and it is the integer, right? And it is the output, yeah, no need set point action. And for this one I need to put the actual value, right? So brow, and then go to see the sensor 1 here, or we can search like this. Example, right sensor and then star and click browse. We will filter only sensor 1, and it is the real right, and it is the precision. Example 2. It means that the decimal is 2 place. So we can save the screen and then example screen 1, and we can run the screen to check. Yes. Oh, like this it's okay. I will adjust the text a little bit to be like this, and then adjust like this. Yes, this one should be like this, and then we can test the screen again. We will got okay. Okay, and then I can online. So right now it show around 7,962, right? And for the actual temperature around 24 degrees Celsius. So let me adjust the milliamp a little bit. Okay, let's see like this. Can adjust like this. Okay. So let's see, compare with the milliamp. Right now milliamp around 8, right? Okay, let me show. Okay, right now the milliamp show around 8 milliamp, and temperature around 24 something, right? So if I adjust to 11, sorry, 12, it will show around 49, yes. 16, around 34 something. 20 milliamp, around 99.87, right? So it nearly 100 degrees Celsius. So if I decrease the milliamp, yes, it will show like this. Okay. So we can test it like this. So if we can write the program inside the ProPC Machine Edition, we can also write the screen to show the actual. Yes. Example, we need to show the one more temperature inside the screen. We can add, yes, but actually we can write as a library, yeah, for this block, and we can drag and drop to use. Yeah, easy to use, because we no need to create one by one. It take time, yes. So we need to create the library and then drag and drop to use. Okay, but in this video I just show and share about how to use the scaling of analog input 4 to 20 milliamp and 0 to 100 degrees Celsius. It is an example. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video also, because my English is not so good, but I just want to show to everyone. Okay, so in this time I would like to request all of you to like, share and subscribe my video also to get more notification and more new video that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye.